Hi everyone. In today's session, we are going to discuss about two of your important combination circuits. One is your encoder, the other one is your decoder. Here, first I have started with your decoder. Why? Because now, always in many of the author's books, I could see that always this topic starts with a decoder and then followed by that you will have an encoder. Because before this, you will be learning always your mux and demultiplexer. Immediately after demultiplexer topic, this will be there. And also in describing the decoder, you could see a statement like a decoder. You could see a decoder is similar to a demultiplexer but without any data input line. Okay. Why? Because now both the circuits will look like the same but not the same. The functionalities are different. If you see the number of input lines and output lines, demultiplexer has one input line and 2 power n output lines, whereas multiplex, but a selection line is n selection lines. There, where in decoder you have n input lines and 2 to the power of n output lines. So both will look like same, so you should not get confused for those things. So first I would like to speak and clear the functionality differences between your demultiplexer and decoder. Thereafter, it could be easier for you to understand the functionality of your decoder and encoder circuits. So for that, to make the work easier, just with a pen tablet help, I have drawn the simple logic of your demux and decoder and I have compared the same. Here, look at this. Over here, first I have taken the demultiplexer. So under demultiplexer, you could see generally with a block diagram, we can speak about a demultiplexer. What it speaks, you have one input line and I have taken a 1 cross 4 demultiplexer, one input line and 4 output lines. So if you have a 4 output lines now, then obvious that n selection lines, 2 power n outputs are there now, n selection lines. So 2 selection lines. So with the help of 2 selection lines, you can indicate whatever the data enters through this one input line. Whatever the data here enters through this one input line, got it? Enters through this one input line, which here in the circuit I have denoted with general alphabet or the variable t. So a series of bit combinations, any number of, either it could be 0 or 1, so series of bit combination could be entering. So whichever data at whichever instant to whichever output line I have to provide, that would be decided by your selection line S0 and S1. Okay. So say suppose if I want the first bit to get transferred to the D2 line, that is the third line of the among the four, then the selection line status for that moment it would be like 1 0. And even the next bit I want to get transferred, then for the next momentary second it would be the same. Say suppose the next two bits, so thereby I'll have my 0 and 1 get transferred over here. And thereafter, say suppose if I want the remaining two other following bits to enter or to be delivered to D0 and D1 respectively, 1 over here and 0 over here, then immediately my selection line has to change from 1 0 0 to 0 0 and thereafter to 0 1. So this is the changes we have to make. So in a circuit, we will provide the input bits through one single input line and input bits, that is the selection that to select the output line to get delivered, where we have to deliver the input from the input to the output is decided based on the selection line status. Okay, so these are the three signals which we would be playing with to indicate to which output line I have to deliver the data, input data through one input signal line. So you're dealing with something called data, series of informations provided, binary information provided through that input signal and delivered to the output line, whichever output line you want to deliver. So here the output line information is spoken through selection line. You're indicating which line through the selection line stated. Okay. Wherein in decoder, here you're not transmitting data. Here data is getting transmitted from the input to the output with the help of the selection lines, indicating which output line I have to get delivered. Wherein in decoder, here data would be either 1 or 0. Input would be always, we will be selecting which kind of data you're going to deal with. Suppose you're going to deal with 1, then you have chosen active high input decoder. Say suppose if you have chosen 0 input signal, then active low input decoder you have chosen. Here the input could be either, the data could be either 0 or 1. 0 or 1. Whereas in decoder, you have to choose which kind of data you're going to deal with, either ones or zeros. Based on that, you will choose. So basically, you have two types of decoders. Okay, so among which, say, most probably in all your budding engineer books, you could find the table with the input signal with the input signal active high input signal 1, where the remaining signals will be made 0. So that means you are dealing with active high input decoder. They have chosen active high input decoder. Look at the logic and the block diagram. Here also, I told you here you don't have selection lines. That is the basic difference between a demultiplexer and decoder. But look at the input and output lines. Instead of calling it as a selection lines, here we call it as a input lines. Input lines becomes your selection lines, whereas their selection lines we call it. Here we call this as input lines, and we don't have something called selection lines separately, only input and output. How many input lines? Suppose if you are going to deal with 2 to the power of n output, n input signals has to be there. So 2 cross 4. So if I want to deal with 4 output signals, then obvious that you should have, it's compulsory to have 2 input lines and 1 enable line to enable this decoder. To enable, which way you have to enable? Either providing the value high or high logic, that is your active. Whether if you have chosen active high input decoder, you will enable through the logic 1. Say suppose if you've chosen active low input decoder, you will enable through the logic 0 with a inverter provided. Got it? So these are the two differences you will have and you will see in your block diagrams. If you choose just if they are symbolizing with E with a simple notation, then simply you're dealing with active high input decoder. Okay, so here the input is either always it's going to be 1 or 0, but not both. Okay, so input is decided here. What kind of data is decided here, but to whom, from whom to whom. Got it? Here the data is decided. Say suppose you're going to transfer 1 to this line of D2 the same way. If I want to transfer first to this, then the input has to be what? 1, 0. That means the inputs are going to speak about the lines which I have to deliver the data. Here the data I have chosen is, already I told you, if you have preferred working with active high input decoder, then the input data you're going to deal with is what? 1. So input data is 1, we know, but to whom to deliver? So here in decoder, the input, from input to output, what you're going to describe now, the line information, the one whom you want to deliver. Say for example, if I want to make an analogy with a postal, say suppose the content I know, but to whom? In the same house, in a house number called 3, in a street named um, Kanaga Street, with a door number 3. But in door number 3, you might have so many people residing. Your dad, mother, there will be n number of persons with n number of relationship, like mother, father, son, daughter, some relatives, in-laws. You could have anybody, but to whom I have to specifically deliver, that is noted just based on the name specifically given to them. Ramaswamy, Ilana daughter Rania, Ilana to the son Rajava. So there it is being decoded. Okay, to whom the information here, information is not delivered directly by the postman to the person. Are there any postman coming to your house and saying the message directly? No, we are hiding that message in a cover and coming and some way with the help of from different place to, so from different country to different country it is reaching. Okay, fine, but later how, to whom, where exactly I have to deliver with a acknowledgement from the same person for the security reasons, registered post and all. Only for security reasons they will deliver only to the concerned person, whether that person is there. Nowadays people are asking for ID card also. Earlier they believed, okay, you are asking, if some, even sometimes father asks na, they will deliver the sons or daughters letters to them, believing that they are nowadays, because of security reasons they are not giving. Ask the same person to, even they will put a digital signature. So this is how the technology is getting enhanced. But only thing is, there anywhere from earlier period also, even to the latest technology in today's era also, the message is not delivered directly. It has been encoded from the sender side, and in the decoder it is being decoded only after delivering the data to the concerned day output line. Okay, here in the circuit we call that Ramaswamy or Kandaswamy or Rani as D2. So the name will be provided on the letter there. Here you are providing the information to whom you have to deliver in the form of binary at the input line of your decoder. Okay, so decoder is a one which deals with the input and output of the information carried by which line, to which line I have to deliver. You are not carrying the data, actual data, to whom you have to deliver the data. To decode that, to deliver that properly, you have a circuit separately called. Also, mux and demux will deal with the data, information, actual data. Here, encoder, decoder will deal with to from whom we are receiving and to whom I have to deliver. That's all. So make note of that. So while that is why while making the statements, they will say that when they ask you to define, always they'll define with that converts the binary information of, what is the binary information? Of n input lines. Of n, which is of n input lines. It is going to speak about the line information of 2 to the power n output lines. Okay. Here it is not going to carry any data. It converts. Which is, what is that it is converting? Na? It's converting about the output line information with the help of n input lines. Okay. So that is why you call or define a decoder as a combination circuit that converts binary information of n input lines to a maximum 2 to the n output lines. That's all. And which is also similar, which will look like a demultiplexer. You might be asking, based on the functionality so far you defined, you deliberately told us it is going to speak about which one. Demux is speaking about your data and decoder is going to deal with a line which is going to carry the data. Here selection line is there, here selection line is not there. Here data line separately was there, the same data line here we call it as a enable line. Here selection line in demux, the same will act as a input line in decoder. Okay, in the other way they have rearranged. So look at the decoder circuit. If you look at the decoder circuit, for the same 1 cross 4 in demultiplexer and for 2 cross 4 in decoder, it will both will look like the same. Both will look like the same if you draw and see. So that is why they call both are similar. Look at this. Here you have the data line, one input line. That line could carry either 0 or 1. So based on the line you want to deliver, you will make that and get enabled. I taught you how that is being made. So through which it will getting delivered. Now in this, The same selection line, it is used as an input line, okay, but still it is going to speak about this, and the same way it is going to work, okay. But instead of D line, you have the same to be replaced with enable line, and here enable line, either it would be high or low, that's all. Always high or always low. That has to be decided first itself. Which IC you're going to pick. You have different ICs of decoder. One dealing with high logic and one dealing with low logic. So based on the sender side, how they have encoded, based on that we will choose the decoder. Okay. So if you look at this, both the circuits will look like same, but the functionalities are different. Here, demultiplexer deals with data, transmission and reception, that is both mux and demux. Here, encoder and decoder deals with the transmission and reception or about the information, line information, okay, not the data. So, these are the reason why those three statements are given always in the first description of your decoder. And why you learn always immediate next to your demultiplexer, first comes decoder. These are the reasons. Okay. So now it would be easier for you to understand what we are going to say right now. So look at this. I told you decoder is nothing but it's again a combination of circuits that converts, or suppose in some of the books you could see converts, or in some of the books you could see it as carries a binary information of n output lines with the help of two n input lines. Other way around you can also write it, both are same. Okay, but you should not mention the data is being transmitted or something. If you write it like this under decoder then it is wrong. Okay, so don't get confused. Next, a decoder is similar to a demultiplexer but without any data input. This line always any examiner will look for while evaluating your paper. And examples where and all it could be applied now, as I told you, to address somebody, to identify the location to where we have to deliver, there and all it comes and plays a vital role. So in memory addressing, to where exactly you want to store your information, for that even a decoder in ROM and all, a decoder comes first and thereafter you will have a array of OR gate. Array of AND gate followed by OR gate. Array of AND is your decoder. So ROM under unit 5 you could see decoder comes first and followed by that you have your OR function gates. Okay. So likewise, it has its own application, and for in digital display also, because one information is getting converted into another, and how it is getting displayed, that you will be designing as one of your circuits, so you could see. Okay. So this is a general block diagram of your decoder with n input lines, 2 to the power n output lines, enable inputs. Okay. Always these things has to be denoted. Now, types of decoder. As a budding engineer, you'll be learning your binary decoder where 2 to the power, the other name of it is what now? 2 to 4 decoder. That is what we have seen right now with a comparison. So 2 to the 4 now, you know how to draw the block diagram. The similar way I have drawn earlier. And what is a truth table? Step 2 is what? Truth table in designing your combination circuit. So always truth table comprises of inputs versus outputs. Here inputs are what? Enable pin and the input pins A and B. Your output is what? 4 lines now, then you can name it Y3, Y2, Y1, Y0. In some of the books, D3, D2, D1, D0. You can take any way, but you have to proceed with the same alphabets. Suppose enable pin is 0 and inputs, whatever the inputs you give, that is why it has been given in cross symbol. Whatever, either this A could be 0 or 1, B could be 0 or 1. Either 0 or 1, we denote with a don't care symbol, that is cross symbol. Okay, whatever it could carry, the input could carry, it won't be, IC won't be enabled and nothing will be delivered at the output. So all are 0. Only when enable pin is high, so it is deliberately teaching, or we can understand they are going to make use of a active high input signal decoder. So whenever the input signal, that is the enable signal, is high, the input data, which we call it as a here as a enable, is high. Based on the input signals, if suppose 0 0 na, it will the data high, this is high, so high logic would be delivered from where high logic would be delivered from here to here. Which line? 0, 0. So, 0th line it will be delivered. Here to the first line, if the decimal value is 1, decimal value y1, here this is the first line. We are telling no. So that in the binary format was 0, 1. With the help of 2 bits, we can denote 1 as 0, 1. Suppose if I want to deliver to the y2 na 2 is a decimal value. What is the binary information I could use to denote the same with the 2 bits na 1, 0. Okay. So likewise, you are denoting with the help of input bits A and B, you are speaking about the line which you want to deliver, which white line you want to deliver. So based on that, it is getting delivered. Did you get it? But always active high logic. So this circuit we call it as a active high logic input decoder. It decodes the information 1 based on the line input line which they are provided. Okay, so if I want to draw this circuit now, always you know, for this you need not go for the K-map and all, straight away from that you can draw. How many output lines? 4 output lines. So 4 outputs has to be there. What are the names? Y0, Y1, Y2, Y3. When and all Y0 is producing the output, when the input enable input is high, okay, high, and when the condition and when the condition is 0, 0. What is that? A bar, A is equal to 0 and B is equal to 0. When this condition prevails, I have the output. So both has to happen at the same time. So that is why I am denoting with the AND function. So if it's an AND function, then AND gate should be used. So here always everything is into E. Okay, in some of the books they will write, in some of the books they will just give the connection. Here you could see the connection, they have given the connection. Okay, so these are the 4 expressions, you have to take it and write it. And based on the expression only they have drawn the thing. Okay, here the expression, logical expression is given. This is your logical expression. And this is a logic diagram. So both are given at the same time. Okay, if you want you can write it separately. So this is your simple 2 to 4 decoder. Also you can similarly you can come out with 3 to 8 decoder, 4 to 16 decoder. So as many outputs you have, those many AND gates will be there, array of AND gates with so many output expressions, logical expressions. And the truth table will also extend. If it is 3 input, then you will have the column C to be added here at the input, and here you will have Y0 to Y7 extended. In a similar manner it would be drawn, so which we will see right now. So this is your 3 cross 8. Okay, this is the truth table. You have to draw it in a similar manner. You have to explain. So here whatever I am saying it verbal, you have to explain it. That is what you will find it in theory, not more than that. The similar way you have to draw the logic diagram. A, B, C. You know this already because you have done mux demux, then it is same like that. Okay, but the functionality is different. So you have to code those functionalities through your verbal statements. So you have to write the theory properly. So it is there in your digital material. Making use of that only I am teaching this. Okay. So you will have, if it's 3 cos 8, 8 outputs and 3 inputs. So this is how you have to draw. Okay. And you can also implement a higher order decoder using a lower order decoder as like your demultiplexer and mux. What we used to do, if you want to implement 4 to 16 decoder using 3 to 8, now 4 now, then you have to make use of 4 inputs are there now. You can make any one of the input to be used as a data line. Here A3 is used as a data. What kind of data? Na? Enable. Here we call it as a enable pin. So to choose one IC at a time, we will give the normal input to the one decoder and the inverted input to the other decoder, so that only one IC will be enabled at a time. Because you know that for a 4 cross 16, if you start writing, your data will be the 4 bits. Now how many possible combinations? These are the possible combinations generally we use to write it. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and then you have 12, 13, 14, 15. Okay, so look at this. For the first 7 cases, always this line is, for the first 7 cases, always this line, which line I have assumed, which I have assumed as A3, A2, A1, A0. A3 line is 0, either 0. If it's 0, with the help of the remaining 3, you can select the, what is that, 3 lines. You can select information 0 to 7. Information 0 to 7. Okay. So making A3 as 0. So if you want to make A3 as 0, then if you provide 1 here, it will become 0 here. Got it? Did you get it? So here if you give 0, this becomes 1. So when the input is 0, you can select or you can make use of A3 to enable the ICs. Here this will be like 0, 0, this IC will be enabled, and these at a time, say suppose if this is carrying 1, 1, that means you are going to indicate the line information which is 7. Here continuously we have written, say suppose for 1 and this is 0, here this would be indicating, sorry, say suppose here 1, 1, here also 1, 1. Got it? Whatever we provide at the same time it will be delivered here also, which is not inverted. Which are the lines? A2, A1, A0. Say suppose instead of 0, if I am going to give 1, what will happen? Here this will be 0 and this will be 1. Okay. So this will be carrying the information 0, 1, 1. Then this line we are trying to indicate. Okay. Say suppose if I want to enable 1, 1, I mean 15, 15th line, this is the information. So at a time we will be having 7, the information 7 and 15. Okay. So with the same combination, if just having this to be high always, and if you keep on changing here these values, say suppose this is 0, 0, 1, here also 0, 0, 1, say suppose this is 1, 1, here you are simultaneously selecting the 12th information as well as here what, 8th information, I mean sorry, what this is 4th information. Okay, so this is how a decoder works. So using if you want to implement a higher order using lower order, this is how it works. Okay, I hope you would have understood. And for that you have to draw this table like this, 4 cos 15. Okay, so in your digital material we are given this. So 0 to 7 first speaks about 0 to, this is speaking about 0 to value 7, and this is speaking about this is speaking about the value 8 to 15. Okay, so this is how it works. And next comes your The same circuit could be 4 to 16 decoder could be also implemented using 2 cross 4. If they ask, you can make use of it. So here 2 lines is used for the common all the 2 to 4 decoder, and the remaining 2 lines are used to indicate or select which decoder. Okay. So here I0, I1, I2, I3 is taken. If you want, you can also take it as A, B, C, D. No wrong in it. Or A3, A2, A1, A0. Everything are the same. Okay. So this is the way you have to implement it. So with this, your decoder is over. In the next video, we can see about your encoder.